This will show you how to do problem number 59 in the chapter 4 homework. Looking at this problem, this one says many Americans have been affected by the opioid epidemic over the last few decades, and you have probably heard about it in the news. The table below shows the number of opioid predictions administered per 100 people in the United States each year from 2006 to 2019. We would like to take this data set and use it to create a scatter plot of the data. So I'm going to first use Desmos. Again, as long as I'm copying from the Word document, I can just copy the data set. And then in Desmos, just paste that data set in. Desmos will set the window the way I would like it to be. If you don't like that window, you can actually go over to your little wrench and change that. But we don't really care that much. We just need to kind of see the shape. And the shape kind of looks what we consider a parabola. So this looks like a parabolic shape graph. I need to tell I want to do is find, if I look at this assignment, I want to find the appropriate model for the data. So I need to find out, I think it's parabolic. I need to know what the basic shape is. So I'm going to go into my chapter, and here parabolic is what I think it is. And that is of the form y equals ax squared plus bx plus c. So going back to Desmos, I will, in the second one, type y. And again, I'm going to type in a 1. It automatically makes it a subscript. I'm going to then put a tilde. The tilde is next to the number 1 key in the top row. And then I can type my a x squared plus bx plus c. And again, I need to tell it which x's I have. So I did want to put in my subscript of x1. So I'm going to type a 1 after that and make it a subscript. And a 1 after that one and makes a subscript. And now I look at this, this really matches nicely with the data. So it does look like I picked the right model. Looking at this, it gives me my a value, my parameter value. So there's my a value, my b value, and my c value. The c value is given in terms of exponential scientific notation. So that's why it's written that way. If you don't like the read as scientific notation, you can write it as a regular standard number. It also gives me my r squared value. If you would rather use your calculator, we will now go see how to use the calculator. So I first need to remind myself what the data looks like. Go into my calculator, go into the stats menu, go into edit. I have data in there already. I'd like to get rid of it. So I'm going to go up onto the name, hit clear, and then hit enter. Move over to the other one, go up onto the name, hit clear, and then enter. And now I can type my data in, 2006, 2007, 2008. Oops, if I type 2008, 2009, 2010, 2011. I just type it all the way in, all the way up until 2019. Again, this is the advantage of Desmos, is it actually, you can just copy and paste. There's no need to type it in. The problem with typing in, of course, is you can make mistakes. So just make sure when you typed it in, you're typing it in correctly and you're not making any mistakes. Make sure your numbers are right. If they're not, you can go back and edit them, but it's better if you got them correct. I did not get that one correct. Keep messing mine up. Sorry about that. 25.6, 70.6, 66.5. And the last one I didn't do right. So I'm going to just make sure they're right because I keep having a problem with typing the wrong ones in. Looks like they're all correct. And looks like I've got them all. Okay, now I'd like to go ahead and graph it. So first thing is I'm gonna need to make sure that I don't have anything in my y equals. So I'm gonna go ahead in there. I do have something in here, so I'm gonna clear that out. Then I'm gonna go up into stat plot. Number one, I want to turn on. It already is on. It already is all set up. So it's all ready to go. So I don't need to do anything there. If it wasn't turned on, I would just go turn it on and then change what I need to. I need to go to zoom, and I would like to do a zoom stat so that it actually fits my axes to my data. You can just hit the number 9 or arrow down to number 9 and hit enter. Now that I've done that, again, it looks very nice. Does look like a parabolic shape. Now I'm going to go to the stats button again. I would like to find my model. We'll go to the word calculate. This is a parabolic regression, or we call it quadratic regression. So I'm going to go down to number 5, which says quad reg, which means quadratic regression. Again, it sets up as L1 and L2 as your list. Frequency list you won't need to worry about. I would like to store this regression equation. So again, what I'm going to do is push the varies button, over to the y varies button, go into number 1 function and pick y1. And then I can go down into calculate. And it comes up and gives me those values, my A value, my B value, and so forth. For the quadratic regression and the linear regression, and I believe in the exponential regression, it will give me my R squared value. Unfortunately, the logarithmic and sinusoidal one, it does not, but it does give them for these two. Now I can go into and write all these down. So I'm going to go ahead and write these down. I am going to write this one by hand because I have a square there. So my y, in this case, you can use any letter you want. You don't need to use y. This is the opioid. Opioid numbers. And I don't think I spelled opioid right, but you get the idea. And T is your year. And then I can go ahead and write this. My y is equal to, my A is negative 0.486, sorry. I'll round it off to 6. And then it's going to be x squared. So if you forgot what your model is, it actually writes it right up here. So it's your A, x squared, plus your B. And my B is 1955, let's call it. And then that's an X. And then my C is minus 19,64931. If I go back to Desmos, by the way, just to show you a little bit about the Desmos there, notice it said it was negative 1.9649 times 10 to the 6. Remember, this is scientific notation. You just move the decimal place 6 places if you want to put it in standard number. So it's 1, 2, 3, 4, 5, 6. You'd have an extra 0 on the end. So in this case, it would be 196490. Whereas the graphing calculator told me it was 19,64931. So it gave me a little bit more. I'd have to have a few more zeros. So it's, again, you're going to move the decimal place 1, 2, 3, 4, 5, 6. You can have 2 zeros there. So it doesn't exactly give you the same accuracy, but it's pretty dang close. 931 or 900, they're not that far off from each other. So it's okay that it wasn't perfect. It also asks for the R squared value. Our R squared value is equal to, and again, you can either use your calculator or you can use the Desmos for this, and it does give me a 0.994. And again, what that means is that there's a 99.4% of the variability in the Y value, the number of opioids, opioid addictions, is explained by the model. That's pretty dang good. That means that model is doing a pretty good job of explaining it. One thing I want to point out on this one is that this graph is going back down and it's going down to 0. So it's not perfect because we do know it's not going to actually go all the way down to 0. Probably there will still be people addicted to opioids, but as they get less and less chances of them getting them, it will get closer and closer to 0. So this is a pretty good model. Outside of our data, it won't be perfect, but it does a pretty good job. So now the next thing I want to do is I want to look to see what else it wants us to answer. Oops, wrong thing. So it wants us to answer, use this model to predict the number of opioid predictions administered in the US per 100 people in 2020. Should your prediction be trusted? So again, we're going to look to see what it says for 2020. The nice thing again about your calculator is you don't have to type it in. Whereas in Desmos, you would actually just have to type it in. So just to show you what that would look like. So I'm in the wrong place. In Desmos, if you want to do this, you could do this and you would just type in your negative 0.9, negative 0.486195 times 2020 squared plus your B, which is 1954.87 times 2020, and then minus your 1.96 1.9649 times 10 times 10. Got my times. My times is this, the star instead of the X to the 6th. And it gives you what the answer is right there. So it tells us it's going to be 22,287. So I'm going to take that number. And actually, the nice thing about Desmos is I can actually copy that number and then just put it where I'm typing. In this case, I'm typing. And so in this case, in 2020, there are that many per 100. And I should go back. I think I'm saying this was addictions, but let's just make sure that that's actually what the problem is talking about. It says it's prescriptions. So this is actually prescriptions, not addictions. So per 100 prescriptions. And ignore the fact I can't spell. Apologize for that. And so I should actually call that prescriptions here. All right. Then the problem also asks me, going back into it, the problem also says, should this be trusted? And the answer is no, it shouldn't be. There's been less and less prescriptions for this. This is just a model. This is extrapolation. So extrapolation should be cautioned. And the reason is because you don't know if this is still what's happening. Could be that opioids no longer prescribed at all, in which case then it would be 0. So you can't actually use that, and so it should be cautioned. It's not too far off though, but it shouldn't be exactly used. And there's one more question it asks us. It does ask us now that use this model to predict the number of prescriptions administered per 100 in 2040. So again, now we're going to go back to Desmos and do the 2040. The nice thing is here, I can just go up here and change this to 40. in my equation. So instead of having 2020, I can make the 2040, and it gives me what that value would be. I'm just curious because I don't think that's right. Because 2020 2040 should be negative. So I'm trying to figure out why that didn't come out right. I must have typed in a number wrong. But this is what you should be looking at. You should be looking at the fact that this number does not actually match what you think should be happening. That makes you want to go look to see what's going on and why that didn't happen. So you could check this out. We could also go to our calculator and try it on our calculator. Since we already have the equation in there, we can actually just go and type in vars, go to y-vars, number 1 and number 1 for the y1, then type in 2040, close your parenthesis off, and hit enter. Yeah, so it should be a negative number. And so our answer here should be negative, which of course is definitely not trusted because we can't have negative number of prescriptions. So in 2024, that's what 2040, sorry, there are negative 345 per 100 prescriptions. This cannot be trusted. I'm curious what the other one would be. So I'm going to go back to my calculator and I can actually ask my calculator to type that in. So I'm going to go in here and I can actually bring back the previous entry, arrow over, make that a 2020, hit enter, and it tells me it's 36. So this number is wrong. I'll have to find out what I typed in wrong to Desmos. But this is 36.3, which says that there's even less and less happening in each year as we go.